Now, there is the original problem. You have a rectangular field, measures 150 feet by 80 feet. Part of the lawn is torn up to install a walk of uniform width around it. The area of the new field is 1/2 the area of the old. How wide is the walk? So there's the problem. I strongly suggest we make a picture, which is what I'll do, and work from there. So hopefully you have something like this. There is your rectangle, and you've torn up a border which is equal distance, which we don't know, so we're going to call that border X. Now we don't know the dimensions of this inner area yet, but in a way we do. But we know the total area is length times width. So if we multiply 80 times 150, we get 12,000. And we know this inner area now is 1/2 of the whole area. So if we take 1/2 of 12,000, we get 6,000. And we actually know this length here. This is going to be 150 minus this x and this x. So this inner length is 150 minus 2x. These are my x's here. And we know this height or width here is going to be 80 going this way minus the 2x. So the other one is 80 minus the 2x. So this is this one, and this is this one. So again, this is our new length, this is our new width, and it's length times width, which will give us half of the overall area, which originally was 12,000, and now it's 6,000. So that's where we are. And you might say, wow, that's quite an equation there. But again, you just FOIL it. This times this, well, we said was 12,000. Now my outers will be a negative 300x, 150 times a negative 2x. My inners, a negative 160x. And then my last, a positive 4x squared equals 6,000. So it looks like a quadratic equation. We want to put it in standard form and collect like terms. So we're going to end up with 4x squared here. We're going to group these two together and get a negative 460x. Now we're going to subtract 6,000 from both sides, and that leaves me then with a 6,000 on that side. And that all equals now 0. Now if you can see it, each of these coefficients or these terms is divisible by 4. So I'm going to divide everything by 4. And this gives me x squared minus 115x. And this is 1500 equals 0. Now again, you could put that into the quadratic formula, but actually in this section all of them can be factored. So this is actually factorable, and since our first term a is 1, that works out very well. And notice what you have here. You have 1500 and 115. Yeah. The will be, let's say, 15 times 100. And they're both going to be negative. And this will be x equals 100. And this one will be x equals 15. Now if x is 100, that wouldn't work there at all. So this is an extraneous root. We just throw that one out. And our answer is 15. So the width of this walkway around the whole thing will be 15. X equals 15. And that checks. Now, what I did is I read the problem carefully. I made a diagram. I'm using my area formula, and then developed an equation. And actually I did the mathematics before I showed it to you this way, so I wasn't stumbling along the way, and checked it out, put that in MathLab, and I was right. Okay, well, good luck with this section. Keep in mind, though, all of the problems in section 5.5 can be done by factoring.